Morning everyone. Today I'm going to deal with the software verification validation for the first session. In this session we're going to learn the main objective of this is what is software testing, why is testing required, how is testing done, when do we start testing, when to stop testing, types of software testing, and what is quality assurance. These points we're going to deal in this session. And the first one is what is software testing. Before going to see the software testing, let me ask you a simple question. What is testing? Testing means suppose you have done some work, we want to test it whether it is working as your requirement or not. That is just like a testing. But if you go with the software testing, so what is a software? Set of programs are accomplished to complete a given task. So in the given task we are going to verify it whether the task is properly tested or not. So in the coming videos you are going to deal with the software testing afterwards. So again, why we are requiring the testing? That means if you know that your software is working well, but is it really needed for testing? That things we are going to see it. Again, how is testing done? So suppose one person is to taste any food, he tastes in one way, some other person is testing in another way. In the same way, in what way we are going to test your software, or someone writes the software, in what way we are going to do that, things also coming in upcoming slides. Again, once the work is done, again, is it mandatory to test at the end, or else is it mandatory to begin the testing at the beginning? That things we are going to see it in start testing. Again, once the work is over, then we have to check with when to stop the testing. Clear? So okay, apart from all these things, sometimes we'll follow one way of testing, some other time we're just following with another way of testing. But so far in this we'll see different types of test cases also there. So we know that black box testing, white box testing, and sandwich testing, fog testing, regression testing. But according to the given software, we're going to working of the type according to the requirement of the software to be tested. We'll adopt different kinds of testing. That things also we're going to cover in the upcoming slides. Again, in the end, what is quality assurance? Once your software been tested, we're just giving its quality. According to that quality, we're giving assurance. So in the slides we're going to dealing with all these objectives. Now coming to this, again, why it is important for that? Suppose we are the human beings, definitely we are prone to mistakes because of intention, or else incorrect assumptions, or else carelessness. Why? Because if you're writing the code, we feel that divide by 0, such kind of errors, we never think of that. But in the end it leads to incorrection of the program, we are not able to correct. So in such cases, if you wanted to test, many of the cases we have to think with a human being's attitude before writing the code. So these are all the things caused for the mistakes of software testing. Okay, we want to eliminate in the beginning stages itself. Okay, these are all traditionally, suppose if I am writing a big sentence, we are just checking that whether that sentence is correctly or not with the help of its syntax. But suppose the text been increasing, it is difficult task to check its phrase. Okay, so here it is following a development life cycle for each and every test case. So in the coming videos we are going to see with the examples. Okay. Now if you want to test, these are all manual test case. Suppose what are the manual test case? First one is requirement verification. Just think that suppose I'm started with the one code, again I want to check with that. The first one is requirements verification. Suppose I'm writing a simple a plus b code for addition of two numbers. What is the requirement verifications? My intention is to verify integer values of 2 and 3 values, but some other cases definitely the user can give floating values like 2.5, 3.7. That means being a manual tester, what they have to do, for the input for the given program, we are meant to give only integer values. Clear what I'm saying? So that comes under requirement verification. Why? Because my requirement is the user supposed to give only input values. Okay, suppose test strategy. Suppose maybe the user by default has given float value, or else long value, or else long double value. or its big precision value. That time how this software testing is able to manage that kind of strategy, we have to prepare that. Suppose the user is giving integer, float, double, or it's a long double, the system is able to take, in the end it has to say that please enter only integer value. That things we are going to maintain in test strategy as well as test plan. Suppose in case of a test strategy it is good, but in case of test plan, before entering into the values from the customer or else the user who is making of the software, we're just giving it a plan, better enter integer value. That kind of test plan we have to prepare, so the customer never go beyond of that. Suppose if he goes beyond out of the boundary, even for that time also we are going to maintain with the help of different test strategy plans. Clear? So in this test case preparation, that means we have to prepare so many test cases. Suppose the user has given only input values, how to handle it, or else suppose the user has given floating values, how to handle it. Suppose the user has given characters, that means or else a group of characters, he has given ONE1. Suppose he has given FIVE5 instead of 5 digit. How to handle that kind of situations? Again, that test case plan we have to prepare well. Again, test case execution. Once the preparation is over, again the test case keep on taking the values, it start executing. Suppose instead of 5 I have typed FIVE. Sorry, it is taking the value but it is not able to execute. In that we have to give in a code like whether if your user has given ONE1 or else 1, the system is going to be executed. So such kind of test case preparation and test case execution strategies we are going to develop for the better use of the user. Okay, once these things are over, then we have to prepare with the defect logging. That means what is error and what is defect and what is bug. So suppose what is error. So in case of software testing, suppose user simply writes the code. Error means definitely prone to logical error or else a syntactical error. If you go with a logical error, that means the way the system is expecting the construct we are not able to write. That leads to logical error. If you go with a syntactical error, that means if you're keeping semicolon or else printf, you are missing f, sometimes pri. Suppose if you're missing any syntax in that time it leads to syntactical error. But if you write any logical mistakes, that means in what way the system is being executed, we are not able to write, in that cases it prone to logical error. So in this defect logging, we are going to maintain all these scenarios into the existence, then only we could able to prepare a good strategy for testing. Again, retesting. Suppose if you test anything, you feel that it is working well, but if you keep on increasing the number of times being executed on the same program, definitely it will take less time. We know the difference between space complexity and time complexity. The moment you've been executing, that we simply call it as code immediately testing. That means the JIT principle. That means it is immediately changing the entire code into machine code. The moment you are asking for that, in the first case it is taking more time. If you go with a keep on increasing number of iterations, it will not take that much time. So this is called retesting importance. And the next one is test report. Before test report, again I'll tell with a simple example. Nowadays everyone doing with machine learning algorithms. If you go with the ensemblers, that means if you impart more than 2-3 algorithms, if you keep on executing, the machine or as a system is adhere the benefits of the previous output, again it is taking input, so it will definitely execute less time compared to the previous testing. Likewise, the retesting phase gives you less time for the better understanding of the machine rather than the system. So that is the reason why it is reducing the time. In the end, we are going to prepare test report. Okay, if you go with the manual, we have to think of all the elements in your mind. That means we have to check with okay, how this test case can done. But if you go with the software lifecycle model, everyone knows that we have CPM/CD, communication, planning, model, modeling, deployment. In the end, we want to maintain all these things. So if you want to prepare these different software lifecycle phases, we want to check each and everything. But if you go with a waterfall model, it is not possible. But the next enhancement model, suppose students, you already studied this, again the prerequisite for the subject is software engineering. We already gone through all traditional models, agile model. So if you compare the starting test with a traditional model like a classic life cycle model like waterfall model, we can test each and every phase once the work has done. But if you want to move back, it is not possible. Okay, so if you go with a V model, it is not like that. It is just like a like this. It is just like a V model. It is also following all this CPM CD version. Again, even for this also CPM CD version, but every time it just going in a vertical direction. Again, parallel it is verifying in each and every constraint. So if you go with the traditional life cycle model, we can start with the requirements phase itself. Once we can start with the initial phase, we start checking. Again, we have to check with a line by line code, what is the thing we can do. Again, we can even doing with the once the entire phase is over, that also we can do. Again, if you go with a V model, we can integrate each and every model, then we can verify. Okay, so this is a phase we can start. Again, when to stop testing? Just think, students, if you completed the testing, that means your code is running good, that is very good. Again, in the previous class, in the previous slides before, I told you how much time it is taking. If you prepare a valid test plan, the time moves on, definitely it is taking less time for the execution. Okay, now look at here, when to stop our testing. Suppose if your code been passed with 10 test cases, that means you already prepared 10 test cases. Suppose I'm just giving the example, suppose my system is expecting only integer value, but you already wrote test case to accept float values also. That means your program is taking even float values. Suppose you are giving ONE1, not single digit 1, you are just giving ONA, but you wrote the code for even taking that string of ONE1 TWO2. That means the system is taking. That means these all the constraints we come across. Once your code is good, but you wrote a code that is meant for satisfying all these codes, then it is passing all the test cases. Once it passes all the test cases, we can stop for that. Is it clear? That is the first case we can stop our testing. And the next one is, suppose you wrote very few test cases, but it is executing each and every one, that time we can stop our test case. And one more, suppose you have been placed a good team leader, but you want to check only one module, but remaining modules you are not paying that much attention. Even that time also, you just verify only that module. Again, whether it is executing well or not. If you go with a test engine, you feel the difference of taking test suite and execution of single test case we can see with the coming videos. But anyway, for the time being, you just try to understand, if the test lead he is interested to execute only one component or also one module, he is not bothered about rest of the modules, that time also we can stop our testing. And the next one, again on meeting deadlines, that means just now I told you what are the test plans you have prepared. If your code is satisfying all, then and there itself we can stop. Again, meantime between failure, you already know that. Suppose if I am giving one input, system is taking, okay, after few minutes it is failing. Again, if I am giving one more input, it is taking, after few minutes again it is failing. Again it is giving, if I am giving one input, it is taking, again it is failing. So here the agenda is meantime between failure always less. Okay, if the system is not prone to this, we are not able to adopt that kind of test case. Hope you can understand meantime between failure. Make sure that it is always, that means the time it is taking less time to failure. Again, we have to maintain better meantime between failure. Okay, here types of software testing. Okay, we were already started with the testing. That means we want to check whether it is correct or not in a different constraints. But here in this software verification and validation, it is broadly categorized into function testing, non-function testing and maintenance testing. Let me tell you what is functional testing. Functional testing means, I'll tell with a simple example. Suppose you are writing one code, that means you are expecting the code should be taken off, it should execute it according to its function. Suppose, let me tell you with a simple int a comma b. Function testing means, suppose if I am giving 2 comma 3, system is going to give 5 is the answer. That means if the system is giving exactly 5, that means it is taking addition function, it is properly executing, in that it is showing its work done. This is called functional testing. So in definition, we simply say that functional testing is a test case. It just takes the given inputs and executes according to the parameters you've been giving. That means it is just executing. That's all. Non-function testing. If you go with a non-function testing or as a performance testing, let me tell you with one more simple example. Suppose if you want to construct a house. So if you go with the function testing, if for the given house we are expecting doors, windows, roof, floor, again different colors. If you go with a non-function testing, but apart from the functional testing, non-functional is just adding performance to the function testing. That means what kind of door we can fit into that, what kind of floor we can make, what kind of windows we can keep it off. That things comes an added advantage or its added maintenance of the given function testing. For that reason, function testing, if you want to construct a house, it is expecting windows, door, floor. That belongs to whether the things are present or not, whether all the things are properly fitting or not for a particular room. That comes under function testing. If you go with the non-function testing, that means what kind of window we are keeping. That means according to the budget of a customer, we can keep high-end windows and we can keep glass doors. Again, we can keep slide doors. That means this comes under performance. Okay, if you go with the software for non-function testing, we can just see with how much time it is taking, again what is its robustness, how much scalability it is giving. Suppose if you are giving one code, this code is running for 10 people on 10 machines, but the same code it is able to working on more than 10 machines. That kind of things we are going to deal with non-function testing. For that reason, the parameters that comes, again we have to verify for non-function testing is robustness, scalability, efficiency, security and many more that things will come. Again, if you go with the maintenance testing, just now I told you functional testing is for whether the given input has properly taken, whether it is executing its operation well or not. We are going to study with the functional testing. If you go with the non-functional testing, it just going with the enhancement features to better valuable for the function testing. If you go with the maintenance testing, we'll see with whether it is working with each and every parameter changes. First, let me tell you what is regression and maintenance. Suppose I want to take weather report for today. Today 9 o'clock, what is the weather? Again 10 o'clock, what is the weather? 11 o'clock, what is the weather? Again, if you go with the regression, what is the weather? It is present at 9:30. Are you clear what I'm saying? If you go with the that means 60 minutes slot, weather been changing. That means at 9 o'clock, what is that? The same weather may not carry forward for the 10 o'clock. Right way. Likewise, but in the middle also there is fluctuations in that. But if you do any changes in the middle of a code, will your code properly executing or not? That things we are going to verify in maintenance testing. Okay, but I just prepare a simple scenario. Again, what are the types of testings that comes under different test categories? And the first one is functional testing. In that, unit testing will come, integration testing will come, smoke, user acceptance testing, utilization, globalization, interoperability and many things will come. I will tell you what is unit testing. Unit testing, another name for unit testing is module testing. Suppose if you want to write simple calculator program, everyone knows that in the given calculator program, it is embedded or else it should embedded with add, mul, div and division. Is it clear? That means in your given program, it should be there with addition, it should accomplish with the subtraction, multiplication, division. 4 modules you are expecting to execute a calculator program. Clear? Suppose if you go with the functional testing, if you want to test with the unit testing, first I am just verifying whether add module, that means add function, is working properly or not. That belongs to unit testing. Or else one more, unit testing, module testing, or a block testing. What is a block? That means it's a set of code. We just want to verify this add is working well or not. Suppose just think that add is over. Again, I want to verify whether my code is taking multiplication or not. Here we are also verifying multiplication, that means whether it is taking two values in the end, whether it is displaying product properly or not. That things we are going to verify in unit testing of multiplication module. Once addition is over, multiplication is over, again we'll go with the subtraction. Even for this also, just verify that if you want to take two values, suppose let me tell you one more example. Suppose I have given 1, in the end I have given 9. Will my system is taking properly of 1 minus 9, in the end whether it is giving properly 8 value or else minus 8 value. That things we are going to verify in subtraction module. Let me ask you one more question, students. Just it is executing addition well, it is executing multiplication well, just addition, subtraction is not doing well. In the end, it is not able to integrate properly for the calculation module. Am I clear? So if you go with the functional testing, one simple example, it just take a particular task, it just try to execute whether the task is done or not. If you go with integration testing, suppose addition is over, subtraction is over, subtraction individually it is working well, division also working well, multiplication also working well. The moment I am integrating, but I am not able to integrate it. Am I clear what I am saying? So if you go with integration testing, after integration of add, sub, mul, div, that means all the parameters, all the modules are working well, then we are going to pass integration testing. You may ask that, ma'am, unit testing, all the things are done well, but why I am failing with integration testing? Definitely it is a possibility of internal parameters why you're taking in what way you are considering. That means the code might be differs. So if you want to integrate it, make sure that each and every parameter is working well for the joint of one module to the another module. And the next one is smoke. I'll tell with a simple example. Suppose any person is he has a habit of smoking. We can sense that atmosphere simply changing with smoke. If you go beyond, the smell may not comes. If you go with the smoke test, okay, if you write a simple code, if you try to execute with the smoke test, that means if we want to verify only that particular module, rest of the thing we are not interested. That is called smoke test. And the next one is user acceptance test. Suppose the system is giving, I am expecting two different values, but the system is expecting two different values. Though I am giving different values, the system should accept first, in that it should take. That things we are going to verify in acceptance testing. Again, localization. Everyone knows, if you write a simple code, you can write certain variables in local. Again, you can write certain variables in global. Local declaration, if you declare any variable inside the local block, that means what we call the life of variables are present only in the localization. Am I clear? But if you want to test with the global, it is not possible. That time what we need to do, we have to extend the parameter values existence from local to global. Such kind of things we are going to verify in localization and globalization. Okay, next one is interoperability. This is also very good strategy. If you go with the software interoperability, first let me explain what is interoperability, then I will explain what is interoperability testing. Interoperability, let me tell you with a simple constraint. Suppose I want to draw money from SBI ATM. That is good. I have SBI ATM card. With the help of my card, I am going to withdraw money from SBI ATM. That is good, but nothing more than that. But let me tell you, I have SBI ATM card, but on my premises SBI ATM machine is not available. That what can I do? Definitely I'll go with some other ATM machine apart from SBI, but still I am able to withdraw money. Okay, 7 to 8 years back it was not possible to draw your money with a different ATM machines. Clear? But interoperability is a good principle that is giving acceptance or else accessible though you belongs to other domain. Okay, now clear. Okay, with this example you are able to clear this. Again, types of testing, if you go with interoperability, that means if you change different codes but still you are able to test the code. If you run your code with the Python, if you run the same code with some other environment, still it is able to work on that. For better example, online compilers are there nowadays, everyone using. That means in that all the test cases plays an important role. All test cases, that means if you write a code in C, it will execute. If you write a code in Java, it will execute on the same platform. If you write the code in some other language, Python, if you write in C++, still it is writing, it is executing. That means that platform is able to withstand with a different working environments. That kind of idea it was there. So even if you write a code in different test cases, if you implement that with interoperability principle, that means it should work on different environments. Many things will come. As I told earlier, apart from the functional, that means apart from the regular execution, we'll go with the non-functional testing. In this non-functional testing, we just want to verify how well it is performing. Again, endurance, that means it's a if you add extra thing, how well it is working. If you add extra load onto that, how your execution takes place. Even I told you scalability. If you're working with the 10 machines, how the machine is taking, how these 10 things are executing. If you increase the same code for 100 machines, how it is, whether your code is scalable or not. Again, usability, that means will you able to use the same code for different constraints and so on, that things will come. Again, maintenance, just now I told you regression. If you take time at 9 o'clock, what is its temperature? If you take the time at 10 o'clock, what is its temperature? In between, how many variations of temperatures will come? How to maintain all these things we are going to see. So if you go with the testing, so suppose if you are giving with the one value, timely value we are giving, that means according to time it will change. Suppose dehash imaging we are doing. If you verify at a smoky side, the image is different. If you see one object inside the light, it is different. If you see any object outside the light, this is different. If you go for the maintenance, every scenario plays an importance for testing. So that things we are going to see. Okay, just now I told you unit testing, integration testing, system testing. Again, in the end, quality assurance. Once all the work is done, well, your program or say it is giving assurance according to the quality or not. Here we have to think with before assurance we have to think with quality and quantity. So what is quantity? Quantity we can measure with its weight. Yes or no? Suppose I am writing a simple code, but a simple task I wanted to provide a code, but the simple task maybe I am using 10 lines of code. Is it clear? That is good. That is quantity. Suppose the quality, instead of writing 10 lines of code, my system is taking huge memory. Am I clear? Suppose earlier days, but now it is not like that. But suppose for the simple task, maybe I am taking 10,000 lines, 20,000 lines, 30,000 lines for a simple task. That means the quality will not come. Quantity is increasing. But when quality will come, if you write a complex instructions in one line, quality will come. Here understand one more point. If you increase more complexity, sometimes you may not make use of that. For that reason, if you go with the Python, you can write all the library files with directly importing all the library files. Do you feel that library file is only one file? No, it should accomplish with thousands of code is accomplished in that with just importing. Manually you are not seeing. If you run with any compiler, it is showing 2000 lines, but you wrote only 10 lines. Are you clear what I am saying? Here you have to understand that means the entire library files you are just importing, but you wrote only 4 lines code, but you feel that 4 lines code will give you the result. But that things we are going to see assurance. That means without including or else without importing huge library files, still you are able to execute. That means it is increase the quality of a given system. Basically we have to give assurance for all these activities for performance of a system. If it meets all the needs of all the requirements, then QA is very good. So with this I am trying to close. Before end of the session, I just want to summarize. Today class we have seen reason for testing, again what are the requirements of testing, how testing can done if it there with the software testing, if it is there with a non-functional, if it is there with the maintenance. Again we already discussed with where to start, where to stop. We already seen different types and also told the difference between quality and quantity. In that we want to give assurance to our customers to give better quality to withstand on the market. With this I am closing first session. Thank you.